All right, guys. In our table of contents for this section, we are going to add today some stuff about deductive reasoning. So if you remember back to when I was talking about conjectures, counterexamples, we talked about inductive reasoning. And inductive reasoning is a good place to start when I want to figure out what's true about a pattern, but it will not prove that something is always the case. It will not prove that something is always true because they're just examples, okay? But it does help me make a guess. Deductive reasoning will prove that something is always true. So that's why we want to use deductive reasoning. Like if you think about Sherlock Holmes, he uses a lot of that in there. So we have our deductive reasoning, which include two laws. So deductive reasoning. Laws of, and they're kind of funky words, syllogism and detachment. We're going to talk about these two different laws. It's not super important that you know, I have hair in my mouth. Sorry, that's so gross. It's not super important that you know like the name, like law of syllogism, law of detachment. It's more important that you understand how to use it, but we will practice both those things today. And I think we're going to put this, we're going to kind of put it on 18 and 19, although we're not going to fill out both pages today. So let's turn to page 18 in our notebook. And this one I forgot to put in your packet of notes, so I really hope you're able to print because there is a lot of writing on here. But I attached it to this video so that you can hopefully print it out. You're going to want to print it out front to back, and you're going to want to flip it over the short edge. And when you do, it looks like this. Otherwise, you're not going to want to write all this stuff out. It's just too much. And we're just going to fold it in half like a book. I'm so mad that I forgot this one because it is a lot of writing. So just in half like a book like that, and then we can tape it in right on page 18. We're not going to do page 19 yet. I'm going to make a separate video for that one, and it's going to be about more deductive reasoning type stuff, but we just want to talk about the laws today. So law of detachment and law of syllogism. Okay, so as I said, deductive reasoning is the type of reasoning we want to use to prove that things are always true. So deductive reasoning uses facts and definitions in a logical order to write new logical statements that follow from those other true logical statements. So we're taking a general definition of something and using it to say that other specific things are true. So we're going from a generalized statement to then say that specific things will be true. Inductive reasoning is the exact opposite of that, where I take specific examples to try to say that generally something is true, which is not a good way to prove things. So we're going from specific to general. And as I wrote here, we use those examples to make a guess, but then I have to prove that that guess is always true. And that's what we're going to get into kind of next week. Right now, we're just going to talk about these different laws and kind of how they work. And then we're going to get into how I actually use deductive reasoning to prove things true. Okay. So again, our law of detachment says, so I want to do some color here. We got deductive reasoning. This is a law of deductive reasoning. And the law of detachment says it's a pattern of reasoning. Whenever a statement P, remember we use the little P's and Q's to talk about like long sentences that we don't necessarily want to say the whole sentence for. So whenever some statement P implies that another statement Q is true, we must logically accept that Q is true. Okay, so the way that we write this out with P's and Q's is if P, then Q. And then if I know that P is true, I must then conclude, those three little dots mean therefore, that Q is true. So means therefore. More math shorthand, okay? So if I know some statement, if P then Q is true, and then I also know that P is true, the hypothesis of that, and that must mean that Q is true. So that is the new conclusion that I can make. So if a conditional statement is true, true, and the hypothesis is true, then we must conclude that the conclusion is true. So that's what we have here, just in words. So some examples of that, and again, I like to use color for this to kind of show where these things are repeating themselves or being true. So if I live in Houston, then I live in Texas. So we have this hypothesis here that if I live in Houston, then I live in Texas. And that is a true statement. Houston is in Texas. You also then say that you do live in Houston. So it's true to say that if you live in Houston, you do live in Texas. I live in Houston. Therefore, that means I can conclude that you live in Texas or I live in Texas. Okay, so I had a conditional statement that was true. I live in Houston, then I live in Texas. I repeated the hypothesis, I live in Houston. Therefore, I can conclude that the conclusion is true. I live in Texas. Okay. If triangle ABC is isosceles, then it has two congruent sides. So we have our hypothesis here, oh my word, that some triangle is isosceles. We have our conclusion is that means it has two congruent sides, which that is isosceles. And then it's repeated that triangle ABC is isosceles. So it's true to say that if you are isosceles, then you have two congruent sides. Then I have some triangle that is isosceles. Therefore, I can conclude triangle ABC has two congruent sides. Okay. Last one. If an angle has a measure of 90 degrees, then it is a right angle. That's a true statement. That's the definition of a right angle, right? So if an angle has a measure of 90 degrees, then it's a right angle. That's true. The measure of angle A is 90 degrees. So somewhere we have an angle A. It measures 90 degrees. So make sure things match up here. We have an angle that measures 90. Then it's a right angle. This is saying the same thing as that. Therefore, I can conclude that angle A is a right angle. Now, if this had said something slightly different, it would not have been true. So if it had said if an angle has a measure of 90, then it's a right angle. And if I had said that angle A is a right angle, which is kind of confusing, I couldn't necessarily conclude that it has a measure of 90 because the conclusions are matching rather than the hypothesis or hypotheses are matching. However, that's a definition, so it's kind of a bad example, but hopefully you know what I mean. We're going to try some more here where you'll see non-examples. So that is our law of detachment. I repeat the hypothesis, and then I can conclude the conclusion. Our law of syllogism, I like more. It's a little bit more easy to understand, I feel. And the law of syllogism says, again, it's a pattern of reasoning, that if a statement P implies that a statement Q is true, so I have a P to Q that I know is true, and then I also have another conditional statement where Q implies that a different thing R is true. So if I know P to Q is true, and I know that Q to R is true, then I know that P implies that R is true. So if P, then Q, and that's true. And I also have if Q, then R is true. Then I can therefore deduce that if P, then R is true. So we kind of have a fun little matching up thing here. We have like P to Q, and then Q to R. And so because these things, because the conclusion matches up with the hypothesis of the other statement, we can then conclude the opposite two things. So this original hypothesis with the final conclusion can also be said to be true. This is one we use a lot, where I have these if-then statements that are all connecting to each other, and then I can finally say that the original hypothesis leads to the very final conclusion. So when we apply the law of syllogism, the conclusion is a new conditional statement, so a new if-then statement, which is super good. This is a fun one to use, I think. Okay, so some examples. If you study, then you do well. Okay, so we have our hypothesis. You study, and our conclusion is you will do well. That's generally true. And then our other conditional statement says, if you do well, which is the same as that one, then your parents are happy. Now that's not stated anywhere else, so that's why it gets a new color. And because if you study, then you do well, and if you do well, then your parents are generally happy, are two true statements. And because the conclusion of one is then the hypothesis of the next, I can therefore conclude a new conditional statement that if I study, or if you study, then your parents will be happy. Okay, so we took the original hypothesis and then the final conclusion, and that was our new conditional statement. Okay, so another example of that, if a whole number ends in 0, then it is divisible by 10. So our first hypothesis, a whole number ends in 0, and our first conclusion, it's divisible by 10. And the it is referring to the whole number. So in the next sentence, if a number is divisible by 10, okay, so that is the same as what I just said, then it is divisible by 5. And nowhere did it say divisible by 5 before. So that gets a new color. So again, because the conclusion of one conditional statement matches the hypothesis of the other, we can therefore conclude a new conditional statement with the original hypothesis and the final conclusion. So if a whole number ends in 0, then it is divisible by 5. Which all those things are true. If a number ends in 0, I know it's divisible by 10. If a number is divisible by 10, then it's also divisible by 5 because 5 goes into 10. So if a whole number ends in 0, then it's divisible by 5. That's true. Because 5, 10, 15, 20. Like if you count by 5s, it all makes sense. All right, so we want to use both of our laws of logic here to make a valid conclusion if we are able, and then we want to try to name the law that we're using. Okay, so again, I feel like color can be really helpful here. So use a law of logic to make a valid conclusion. If A and B are right angles, that's my hypothesis, then A is congruent to B, and that's true. So if they're both right angles, then they're congruent to each other because both their measures are 90. Then it says that angle A and angle B are right angles. So I said that. It was my hypothesis. And because there aren't two conditional statements, it can't be the law of syllogism. It could be the law of detachment, which law of detachment says if I repeat the hypothesis of a conditional statement, then I can conclude the conclusion, which I have. So therefore, I can say angle A is congruent to angle B by the law of detachment. Okay, another example, if Ben gets a job, then he can afford a car. If he can afford a car, then he will drive to school. So I noticed some things here. We have Ben gets a job, he can afford a car. Also, I notice I have two conditional statements, which leads me to believe this might be syllogism. He can afford a car, I repeated, and then he will drive to school. I've said that nowhere else, so that gets a new color. Okay, so because I have two conditional statements, this might be law of syllogism, and law of syllogism says that if I repeat the conclusion in a new hypothesis, so if conclusion and hypothesis match up, I can make a new conditional statement. If Ben gets a job, then he will drive to school. That is the law of syllogism. Okay, last one here. If angle A and angle B are right angles, then the measure of angle A is 90 degrees and the measure of angle B is 90 degrees. Angle A and angle B are right angles. Gosh, I feel like that was one I already did, but I don't know, let's see. So angle A and angle B are right angles is a hypothesis here. Then we have the measure of angle A is 90 and the measure of angle B is 90 is a different statement. And then they said that angle A and angle B are right angles again. So that was my hypothesis. And again, I don't have two conditional statements here, so I can't be the law of syllogism. It might be detachment. And detachment has to repeat the hypothesis. And we did. So therefore, we can conclude the conclusion that the measure of angle A will be 90 degrees and the measure of angle B will be 90 degrees. And that is detachment now. All of this maybe seems a little silly to say, but again, it will make more sense when we have to start proving things. Like, kind of, yeah, we said a lot of the same stuff there, but hopefully you'll see the purpose of this tomorrow or the next time we talk about proofs, because we're going to start using these to prove some things about line segments. These ones I think we're going to save to do in class together because I feel like this video is very long and I don't want to make you watch a very long video. So hopefully that doesn't seem so bad. All right, see you tomorrow.